Major funding for this program was provided by the Batchelor Foundation, encouraging people to preserve and protect America's underwater resources.
Earth is a liquid planet. 70% of its surface is covered by water. Yet much is still unknown about the depths of the oceans. They call it inner space, an inhospitable environment difficult to explore and unfit for human habitation. Nevertheless, scientists have figured out ways to work and live on the ocean floor.
Aquarius is the only operating undersea research station in the world today.
There are very few people that get to do this kind of work. This is like getting into a submarine, except we can swim out anytime we want.
The Aquarius Reef Base gives researchers around-the-clock access to a coral reef ecosystem. Over the last several decades, coral reefs around the world have drastically declined in health. Now, scientists fear that a change in the chemistry of the water could add further insult to injury.
Ocean acidification occurs when CO2 dissolves into seawater and it reacts with the water to make an acid.
Aquanauts living at Aquarius are the first to study this process 24/7 using new high-tech instruments. What impact might ocean acidification have on the reef? What else might the scientists' findings tell us? It's America's inner space station. The Aquarius Undersea Laboratory is located inside the Florida Keys National Marine Sanctuary, 60 feet below the ocean's surface. Each year, the lab hosts several 10-day research missions that give scientists 24-hour access to the nearby coral reef.
By living underwater, you get 6 to 9 hours of dive time on the bottom down to about 100 feet every single day. That's way more than you would get if you were diving from the surface. So if you're doing experiments or surveys, it gives you a ton of time to work underwater.
Aquarius is owned by the National Oceanic and Atmospheric Administration and operated by the University of North Carolina at Wilmington. A full-time staff of 12 maintains the facility. They work in no ordinary place. Prior to each mission, the crew has to get the habitat ready for human occupancy. An umbilical containing hoses and cables connects Aquarius to a life support buoy on the surface above. It provides power from generators, communication with the outside world, and life-sustaining air supply from compressors.
There's a huge air storage bank that we turn on as soon as we go down by opening valves. The compressors are really only refilling those banks, so that would last the habitat probably 2 weeks.
One of the challenges of living below the sea is getting supplies to the habitat without getting them damaged or wet. In the ocean, pressure increases with depth. In and around Aquarius, the pressure is 2.5 times that of the surface. To transfer the supplies to the habitat, the crew uses modified paint pots.
We do potting transfer to the habitat with supplies virtually every day during a mission so that we can take tools and things like towels, computers, down in pressurized pots and keep it dry.
Meanwhile, the scientists are also busy preparing for their mission. Their instruments and equipment need to be checked and readied, and they must undergo a week of intense dive training prior to living on the sea floor. A team of 6 aquanauts will be living at Aquarius, 4 scientists who will be studying ocean acidification on the reef, and 2 habitat technicians who will do maintenance and ensure that all systems are running smoothly.
RV Bond, outbound crash corner.
It's day 1 of the mission. The seas are rough, but the aquanauts are excited to get started.
You know, you're just anxious to get in the water and drop in and get to work and enjoy the underwater experience.
In a way, you're sort of inside the aquarium. You're the fish in the fishbowl now, you know? That'd be kind of a neat experience, I'm sure.
A technique called saturation diving allows the aquanauts to be able to live and dive at 60 feet below the surface during their 10-day mission.
Most divers go down for what they call no decompression dives, so they're severely limited on the amount of time. For instance, on an air dive to 60 feet, you would have 60 minutes worth of a bottom time before you'd have to leave the bottom and go to the surface.
Surface divers have limited bottom time because the human body absorbs nitrogen from the compressed air divers are breathing underwater.
The length of time that you're in the water and the depth that you're at, that's what dictates how much nitrogen you're absorbing. And what saturation means is that at any given depth, that you've absorbed all the nitrogen that you can absorb. So you can't take any more into your bloodstream, so you're saturated. So we utilize that, say, okay, wow, so now we can go diving out of the habitat. If you stay at 50 feet, you have unlimited bottom time. But there's a set of saturation diving tables that allow you to make excursion dives down below 50 feet. So you still have limits, but the limits are pretty good.
Diving beyond the limits dictated by dive tables puts a diver at risk of decompression illness, commonly known as the bends. The bends are caused by nitrogen that expands in the bloodstream as the diver ascends to the surface.
If you take a balloon, you have air in it, even at 50 feet, they're at 2.5 times the pressure. So that balloon's going to expand 2.5 times on its way up to the surface. So the same thing happens in your bloodstream. So you've been absorbing nitrogen in your bloodstream and in your tissues. Now you take that same bubble and make it 2.5 times larger and make it try to flow through your veins. It starts swelling up your tissues, your joints start hurting because of that, you know, all that pressure inside.
If you come to the surface, you'd fizz like a Coke when you pop it open.
But as long as the aquanauts stay on the bottom, they are safe from the bends. At the end of their mission, the Aquarius habitat turns into a decompression chamber, allowing the surplus nitrogen to exit the aquanaut's body safely before they return to the surface. Since ascending to the surface without decompressing is potentially fatal for the divers, they wear special dive gear to keep them safe while they're out exploring the reef during the 10-day mission.
It's a combination of technical diving and cave diving. That's why you see the redundant systems on here. There's 2 100 cubic foot aluminum cylinders to give them a maximum volume to maximize their dive time, because the whole idea behind diving out of the Aquarius underwater habitat is to get your maximum dive time. We give them plenty of air so they can get up to 2 hours at a time before they have to come in for a fill.
As soon as they hit the water, the scientists are ready to go to work.
Launch one.
So what we're looking at in the process of ocean acidification is the uptake of CO2, primarily from all the fossil fuels that we're burning and pumping that into the atmosphere, and the ocean's taken up almost half that up to this point. And that CO2 is converted to carbonic acid, and that creates more acidic conditions.
Lowered seawater pH resulting from ocean acidification could have potentially devastating impacts on ocean ecosystems.
A lot of the animals in the ocean produce calcium carbonate skeletons, and the change in pH is leading to a reduction in their ability likely to produce their skeletons.
Coral reefs are feared to be severely impacted by ocean acidification.
Just like we make bone out of calcium and phosphate, corals make their exoskeletons out of calcium and carbonate. So we're concerned about a loss in the carbonate ion concentration.
Over the last 10 years, the carbonate ion concentration in the oceans has decreased by roughly 10%, and it is predicted to decrease an additional 30% by the year 2100. Geologic records show that atmospheric CO2 levels have been high at other times in Earth's history, but the rate at which the current change is happening alarms scientists.
It's changing much more quickly than it ever has in the past, according to the geologic record. If change is slow, there's a pretty good likelihood that animals and communities can adapt to that change. But if the change is very rapid, then there's a very high likelihood that we're going to lose a lot of species because they simply cannot change as quickly as the CO2 levels are changing. And it's absolutely a man-made problem.
Unless we curtail the input of carbon dioxide into the atmosphere, there's no stopping it.
About a decade ago, scientists first discovered that the pH in the oceans is dropping. Since then, laboratory studies have shown that lower pH levels drastically impact corals. This Aquarius mission is unique in that it is the first ocean acidification study in which aquanauts conduct various experiments and take continuous measurements while living out on a coral reef.
The purpose of it is to move us out of the laboratory where there's only a limited number of variables being dealt with. We're moving out to an actual coral reef ecosystem where there are many other variables at work. And so our primary mission is to examine what's happening on a local scale.
The aquanauts want to distinguish acidification that is occurring locally on the reef from the ocean acidification that is occurring on a global scale. To do so, they're using several high-tech instruments to take measurements of the chemistry that affects coral calcification.
We've got a very fancy instrument, one of a few in the world. It's called an in situ membrane inlet mass spectrometer, a MIMS. It's capable of continuously monitoring the CO2 concentration of the water and pH next to the bottom and up in the water column. And we're going to look to see what happens on a daily basis.
While the scientists are busy conducting their experiments on the reef, 3.5 miles away at the Aquarius shore base in Key Largo, Florida, the watch desk is keeping in touch with the technician inside the habitat.
All right, so they're at 55 minutes. All right, sir, thank you.
The watch desk also communicates with the dayboat crews.
Roger Bond, undersea research copies.
And monitors the Aquarius systems around the clock.
On this one monitor, what we have is a live chat, but it also serves as an official log of everything that has happened throughout each day and the mission. On this monitor here, we've got 2 exterior cameras and 2 interior cameras for monitoring purposes for ourselves, and also go out on the web for people to log on and see what's going on with the missions. We have a program that allows us to remotely monitor life support systems, both from the habitat and from the life support buoy itself.
The aquanaut buddy teams working on the reef swim to one of the nearby gazebos every 2 hours to let the tech inside the habitat know they're okay.
Gazebo, Aquarius, you read us!
And to refill their air tanks.
Making sure the valve is secure and we will center the reef.
They can plug into a fill source without taking their gear off their back. The fill whip is built in so they can plug in, open a valve, and their tanks fill.
After an average of 6 hours of working on the reef, the aquanauts return to the habitat for a 4-hour break before they go back out for another dive. They enter Aquarius via the wet porch. This is where they store their dive gear and shower before entering the main lock of the habitat. They live in tight quarters, but they have everything they need.
Here's our little kitchen, and as you can see, we've got a microwave. Here's our food. We start with pasta, chicken, and so forth. So among our favorite foods are chips, You get them in these vacuum containers, and you can see what happens when you take chips from 1 atmosphere pressure down to 2.5 atmosphere pressures where we're living. It just crushes the can right down. So you get lots more chips, it's just that it's smaller servings. We don't use flames down here, so we have a hot water tap. You don't want to stick your finger in it, it's very hot, absolutely boiling, so we can have oatmeal or anything else. We can make coffee.
The divers need to eat a high-calorie diet to counteract all the calories they burn diving. They have a little seating area with a large porthole, a bathroom, and several computers, which give them around-the-clock access to their instruments on the reef as well as the outside world.
Okay, here's our bunk room. Little workbench right by the wonderful viewport.
Throughout the mission, the Aquanauts receive continuous support from a team of scientists that make daily dives from the surface. Each night, the Aquanauts call the watch desk with their dive plan for the next day.
It would be easiest to move off the sponge tomorrow, and we talk about doing the sand rubble.
Sounds like it's going to be fine, and day boat should be out about 10 to 4 tomorrow.
I think we have a plan here.
4 days into the mission, the scientists are excited about some of the preliminary data they collected.
We hypothesized that we would see much lower pHs right down next to the bottom simply because of all the local input of CO2 from respiration. And we're seeing that, in fact. pH drops significantly, probably about a 2% lower pH than in the water up above. We're watching those animals breathe, and as they breathe, they take up the oxygen and they release the CO2, and the CO2 reacts with water to make an acid, and it drops the pH into the acid range.
Such lowered pH levels could not only have an impact on existing corals, but they could also make it more difficult for new corals to settle on the reef and grow. Florida is home to the world's 3rd largest barrier reef. But over the last several decades, coral cover has declined drastically. 2 species, staghorn and elkhorn coral, have virtually disappeared and are now listed as threatened on the endangered species list. As once magnificent coral reefs have turned to rubble, other species, such as seaweed and sponges, have become more dominant.
Sponges are animals, and they breathe like we do. Think of a barrel sponge as a hollow tree stump. They take water in through the bark and pump it up through the hollow. During that time, they're removing oxygen, but they're also doing other things. They are feeding. They convert those food particles into dissolved nutrient elements and carbon dioxide.
The scientists are using harmless dye to see how fast and how far the sponges are pumping water as they filter feed.
Well, we were out to measure how sponges are contributing to the change of chemistry in the water that covers the reef, and part of doing that is going to know how the water's moving around, and sponges are a big component of moving water both vertically on the reef and then just sort of recycling it down on the bottom. We also have instruments that are measuring pH at the same time, so we can see how the input of carbon dioxide, say from respiration of a sponge, is changing the pH down current from that sponge. So it looks like what sponges and other animals are doing down there really is changing the chemistry down near the bottom where everything is living.
The researchers hope that the information they collect will help managers to determine if corals can survive and grow in these changing conditions. And if not, what needs to be done to make coral recruitment possible again. Florida's coral reefs hold great economic value for the state. Reef communities form specialized habitats that provide shelter, food, and breeding sites for many marine species. About 40% of marine fish spend at least part of their lives on reefs. Because of this, these habitats contribute greatly to the state's commercial and recreational fisheries. Fishing along the reefs combined with the tourism they attract brings several $1 billion to the state annually.
Divers in the wet porch, you have about 4 hours left on your dive.
While the aquanauts spend most of their waking hours working, they do find some time to observe the abundant wildlife that lives around Aquarius.
This is my first saturation mission. It was awesome. It's a big learning experience. It was hard to stay focused most times just because of everything else going on. I'm supposed to be out there working and you see the 200, 300-pound Goliath grouper, but I stayed on task.
After about 2 days, you tend to forget about the surface. When I was a kid, the big dream was to not have to come up. Well, here I am, don't have to come up. It's great.
At the end of the 10-day mission, it's time for the scientists to return to the surface. But before they can do so safely, they need to go through decompression.
We closed the main doorway between the wet porch and the entry lock and shut that down. It's an O-ring sealed door, pressurize it.
Once the door is sealed tightly, the pressure inside the habitat is slowly reduced until it equals that of the surface.
So we just open up a valve and start venting the gas. And that changes the pressure inside slowly over time. There's a set rates, there's set times, so that your ascent rate is very, very controlled.
This slow adjustment in pressure allows the aquanauts' bodies to safely shed the excess nitrogen that is built up in their bloodstream and tissues. The entire process is closely monitored from the watch desk.
Aquarius, watch desk.
Habitat is Nate.
Nate, how's things going down there?
Everybody's feeling great. Tip top.
What's for dinner?
It looks like some people making some quesadillas and trying to burn up the last of the salad so we don't have to leave it behind.
All right. I will be talking with you. Thank you.
All right, sir. Thank you much.
The decompression process lasts throughout the night for a total of 16.5 hours.
And we hold them at 0 feet for half an hour to make sure everybody still feels okay. Because the habitat is a chamber, and if someone suspects that they're bent at that point in time, it's easy, you just treat them right there and then. Just recompress the habitat and then go through a whole process of decompression all over again.
The next morning, it's another rough day when the boat support crew heads out to the habitat to pick up the aquanauts. But before they can exit Aquarius, they must repressurize the habitat first to be able to open the door to the wet porch.
That usually lasts about, 10 or so minutes. And then you open that doorway and you go back out to the wet porch.
Verify divers in the wet porch.
We have little pony bottles that they use with a regulator on them instead of full dive gear, and they're mask and fins, and that's it. They go out like that. Up an ascent line, a very slow ascent to the surface, and there's a line they follow right to the back of the boat.
Oh, it was great. It was a good mission. It's a good mission. We got a lot done.
On the way back to shore, everyone is in good spirits.
It's always fun to be on the frontier of ocean science, and that's what this mission is about.
Once they are back on land, the aquanauts are monitored for an additional 12 hours to ensure they're not suffering from decompression illness. All around, they've had a successful mission, and the scientists are excited about their findings.
What we found was a very significant difference between the overlying water and the bottom. And what that really means is that the corals and other calcifying organisms that live there are actually not just subject to ocean acidification from the global change, they also have to deal with the local effects down in what we call the benthic boundary layer. A couple of centimeters off the bottom, pH was considerably dropped, especially at night when a lot of respiration was going on and there wasn't any CO2 uptake, CO2 causing ocean acidification.
Another mission to continue studying ocean acidification at Aquarius is already planned for the following year. Ultimately, The scientists hope their research will aid managers in devising policies that help protect coral reefs. They also hope their work will help to educate the public about how human activities negatively impact one of Earth's great natural resources.
We are the cause at this point of ocean acidification by increasing CO2 in the atmosphere. And it's a great hope of mine that we could change our behavior, find alternatives to things that are really causing damage to our environment, because if we don't find solutions to these problems, coral reefs today, it's going to be humans down the road.
Major funding for this program was provided by the Batchelor Foundation, encouraging people to preserve and protect America's underwater resources.